I'll move on to ways to do things that are outside the GUI environment for both vCell and capacity. But in order to do that, I wanted to first introduce you to something else. Okay. So let me open up. How many in the project tracks have used an exchange standard like SPML to bring in a model from outside or switch between capacity and vCell? Anybody?
Well, in my breakout room, at least one group did that, but I think two perhaps even.
Okay, so I think Michael talked a little bit about standards on the first day, or there was a link to that.
Yes, I did.
Yeah. And you introduced both SPML and the Combine Archive?
SEDML. I didn't mention Combine Archive.
Okay. So you mentioned SEDML.
Yeah.
So in order to move this, I took a little model here that I need to fix this new computer. That shows a nice oscillatory behavior with multiple simulations. And you know, as you have all learned, in virtual cell, you can have more than one application, more than one simulation, and you can export all of those informations in the SEDML format. But in order to use SEDML, you also need the model component, which needs to be exported in SPML, and additional metadata. So there is this standard that is just like a zip archive that's called a Combine Archive, where you can put everything in there and give it to another simulator that supports that. And it will execute everything in there, any number of application simulations, models, with changes, with parameter changes. So what you would do is, I mean, to make things simple, I will just use the one simulation for now, but what you would do is say file, export, and choose here Combine Archive. And we'll put it on the desktop. And the question that you get, should you use the native format for virtual cell that will allow you to export any virtual cell model, that some of them are not translatable in SPML because of various unique features of vCell. But if you want to go elsewhere, you can do SPML. So whichever language is, now you have a Combine Archive where there exist tools where you can script and run this on an HPC cluster or on an online platform called Biosimulations that we've developed with many other tools that support a new, very simple API that says input omics file, output HDF5 format with all the data. So somebody had asked, I think on Monday, about requiring to run, 10,000 or 100,000 on a cluster. Well, it's easy to do. What do you need to do for that? Is I will show you right now. Let me bring in okay, so need to make this at this resolution. It's a little bit more painful, but it helps to see everything. Okay, so this is just for those people who are familiar with Linux and SSH and clusters, and just my particular SSH client that I'm using. And I will log in into the submit node of our cluster here at Yukon Health. And I will run an interactive session, which simply gets me to a node on the cluster. So right now, I can run with either Capacity or vCell or Tellurium or Gillespie, any number of simulators that have been containerized, by pulling the appropriate Docker container, transforming it into a Singularity image, and then run it on the run it with the exact same command: Singularity execute container name minus input omics file minus output where to put the directory of the HDF5. So I'm not going to go through all those steps, but anybody who's not familiar on how to get a Docker container and use Singularity, you're welcome to. We can always do a separate little session, or you can just email me. But if you're somewhat familiar with that, I'll tell you where to find things, which is GitHub is packages, simulators vCell, and this is the Docker image. And you can always use the latest tag, or you can ask for a specific version. Where am I here? So you can use a syntax like this: Docker pull this latest. And this is how you pull your image. And obviously I've been using the image, so it's already there, and it's up to date. But other than that, you would get like a little string of getting the image, and then you can make the Singularity image from the Docker image. And then you can run that in a simple Linux script using the Slurm or whatever, controller, batch controller your HPC cluster is using. So the functional difference that Les is asking between exporting VCML and SPML is that, yes, with VCML, you can execute combine archives from the command line for any type of solver and any type of model that cannot be exported to SPML. So there's additional functionality. However, with the VCML one, you can only run it with the vCell container. So what other containers are out there?
Well, I'm just trying to understand what, I mean, if you had a VCML file, that would be a complete version of the model, right? Just
yeah, but
VCML file would be a complete description of the model that you could load, obviously only load into vCell, but functionally would do the same thing.
Nope.
As putting
because
it
in
into
setML, you would actually specify what to execute. So your VCML in the container can say, setML, take this simulation, run it for 10 seconds, and then change this parameter and run it again, and then change this parameter and run it again, and run it again, and run it again, and run it again. So the combined archive with the setML format has more information that you can start editing and scripting than what is saved inside the VCML.
Mhm.
And maybe I should actually show that. Okay, the one that I had just exported, right? So this is the SPML model file. This is the setML. We also include the original VCML for troubleshooting purposes. So this was exported by me a few moments ago using SPML format. So if we look at this, you will have a list of simulations and a list of tasks. So you can use that particular list of models, list of tasks, list of simulations. And here it's like uniform time course, initial time, end time, number of points. So this is taken from the default simulation settings that were in that biomodel. But what you can do is you can then edit this without touching the VCML or the model or the SPML and say simulation 2, simulation 3, simulation 4, where you can start changing things and anything from what algorithm to use, what parameters to use, and then generate any number of list of tasks that the container will execute for you given the model. So for the scripting purposes, this gives you a lot more than, it gives you a formalized, simple syntax that you can use to call from a shell script from within Python, etc., to take a model and execute it in many different ways. And there's multiple containers that have the exactly same. So if you go to biosimulations.org, you will find a platform that has multiple biosimulators that have been containerized with the same user interface. And here's a full list. And all the ones that have this little icon like this, it means you can execute simulations with this online on this platform if you give them a combined archive. And that would be here. New computer, sorry, I have to give everything. And say, run a simulation. And we can upload the local file. And the prompt will show somewhere. Sorry. Okay, keeps going on the other screen. Desktop. Okay, so now once I uploaded this, the platform will actually determine which tool has the capability to execute what exists in that combined archive, that they support the algorithm that's required, that et cetera, the format. So you will see that a number of them are grayed out. So you could use, for this particular one, you could use Amici, Capacity, GilaSpy2, libSPML Sim, PySys, Tellurium, and Visa. So let's use Tellurium. And you can, there might be more than one version of the tool that exists on this platform. You can give it some name and run it. And you will see the status of it. You could put an email there. You can visualize results. And here are examples of other simulations that are publicly available where you can export the data, visualize the data locally from plots defined in setML, and you can select what you want to plot. But what I want to point out now that we're reaching the end is that on this website, let's go back, the links to export data, if you look at the bottom, I don't know if this is visible. Let me make this smaller. So rerunning. Okay, let's see. Download it. All those are links to a site called api.biosimulations.org. So api.biosimulations.org actually exposes all the functionality there through a standardized REST API that you can call from your favorite programming or scripting language. And the full documentation, essentially, you can do get, post, puts, run a simulation, validate it, get the files, download the files. So for everybody who's into automating and programming things, you have everything available through a REST API. And I think I will stop here.
Ian,
Yes,
is there a limit on calls?
a limit on cores?
Is there a limit on API calls?
No, not yet, but if it
Okay.
becomes popular, there will be.
Okay, just a question.